soon you know it. They got another nice display that's updated every day. It's the winter season snow water content for the northern, the central, and the southern Sierra. Climatology is the black curve here. The all-time record year is 82-83, which is shown up here. Can show how much we can really get if the Sierra puts its mind to it. On the other end is 76-77, which is the all-time low here. These are for comparison. That's that dash line on the bottom. The green is last year, and the purple is this year. And if you look at the central Sierra, kind of the middle, right around where we are, last year was low all the way through. This year it started on the high side, but then it just stayed the same. It started to decline, and now we're actually below last year from a snowpack standpoint. Another display you can get, this is from one single SNOTEL station. This is up at Donner Summit, the Central Sierra Snow Lab. It's about 6,900 feet. It's about 2 miles over the summit. When you're going around that one curve there, it's off on the left-hand side in the woods. And this is the winter ending 2 years ago. Long-term climatology for snowpack and for precipitation. There's the climatology. There's how the winter actually was. Very late. And then it finally melted out in well into June. Last year, right here, again, it's climatology, and there's their snowpack. And this year has a kind of a different shape to it. Again, the climatology, and it went up fast. It sort of stayed flat, and it's melted out. It's you go over Donner, and it's well on its way to summer. And NRCS has got some nice graphics that summarize combinations. It's not single sites, but these are combinations of a bunch of sites lumped together in the Truckee Basin, the Carson Basin, the Walker Basin, and then over in the eastern part of the state, the upper Humboldt. And I don't really need to go through them because they all show a similar kind of thing to what I was just showing for single stations. But you can find these on the web, and Nina's put these on this dashboard. So you can, the idea is to kind of be able to look them up pretty quickly. But another point here is over in the Humboldt, there's their climatology. They had that big year 2 years ago, and then last year and this year, which is almost melted out in the upper Humboldt. So kind of 2 years in a row that are sort of similar. They haven't quite shared when I've been mentioning these above normal precipitation events. That's been a little bit more south of there in eastern Nevada, and this gets to a point I want to get to it toward the end here. I borrowed this from Gary Barbato at the Weather Service. These are some from a group in Chanhassen or Minneapolis, the National Operational Hydrologic Remote Sensing Center. If you can say that, I think you're doing pretty good. It's called NORSC, and they keep track of snow spatial patterns in the United States. And this is the extent of snow, which averaged 18 inches of water content 2 years ago. Last year, 4.5 inches. And it's hard to tell by looking down on things because you can't tell how deep it is. And if it shrinks just a little bit, the area stays almost the same, but the volume of snow can really decrease rapidly. But it's noticeable the difference between last year and this year on the beginning date of the year. This is both April 1st, and it's noticeably different this year, and it's 3.5 inches. So this kind of just shows what you can see out the window there. This is the snow water content in terms of percent of average across the western states, and they don't even show Arizona because most of them are melted out and they're now zero. California isn't shown on here because it's not part of the SNOTEL system. California's got its own snow measuring system, so it usually doesn't show up on NRCS graphics. We're trying to put those two together for certain things so that it all shows up at once. California got started before the federal government did at doing this. But you see a lot of red here, and the reds are in the lower percentages. The places that are above average are up here in parts of Wyoming and along the northern tier. This is the snow water content. These are updated every day. This is yesterday. And this is the amount of liquid, or the amount of rain or precipitation that's fallen in terms of its liquid content, percent of average since the beginning of the water year. And you can see the greens are in the yellows are in the 70 to 90% range, and the tan or orange color is in the 50s and 60s%. And the greens are up in the 90 to 110. So that's kind of overlapping around average. You can see the pattern is generally higher in the north and less in the south. So I borrowed some graphics here from Gary Barbato. I'll step you through them. And there's 4 of them here for 4 rivers in the area. So we want to talk about what are the effects on the hydro systems, okay? So the first one here is our own Truckee River, measured at Farad, just upstream from Reno, as of a couple days ago. And there's a bunch of things on this diagram. They're a little complicated, but they're pretty neat once you understand them. So they go from October through September. They're trying to predict this main runoff period here of April through July, which is when most of the snow comes out of the hills. And down on the bottom is the measured daily flow, right here, in terms of thousands of acre feet per day. And you can see those 2 events. There was one here in November and then a big one in December. And where the flow really went up, and then it stayed kind of flat. It's come up lately, but that's because the snow is melting. The orange dots are the official forecasts that are put out in a manual way, starting at the beginning of the year. And because they've had this really wet period, they're expecting, it's looking like it's going to be a pretty good year. So the forecast was for 300,000 acre feet to come running out of the Truckee River. Long-term average is about 258. That's what this line is right here. Then we went a little while and didn't get any precipitation, so about the beginning of February, I said, we're changing our mind, it's only going to be 210. And then about a month later, I didn't get much precipitation, it's about 160. And then another month later, and we didn't get any precipitation. Now it's down to 105, is what they're expecting. So these are the forecasts. And the green is an automated system called ESP. It's not like this, it's extended stream flow prediction. It's a sort of an automated attempt at getting a pretty close guess. And the idea is that you kind of want to know what people were thinking back then because that influenced their decisions, okay? Whether for water rights or all kinds of other uses. But the forecasts have just been steadily dropping. And meanwhile, now we're starting to measure how much is actually coming. That's this purple curve. That's the last item on this graph. And the forecast is for this whole period, so if it's right, it'll just shoot over to the right-hand side here, and this will come up to meet it, and these 2 curves will coincide by the end of this period. So that's what's on this diagram, okay? So it summarizes a lot, but once you figure it out, it's kind of straightforward to interpret it. So this is the Truckee River. Here's the Carson River going south of here. Same kind of deal. They didn't really get that second storm in December. The first one in November. They got a smaller pulse. It stayed pretty flat. It started to come up a little bit. It's kind of looking like this weekend is going to be the peak flow. And I'm kind of using that term advisedly because the peak is sort of like the highest mountain in Florida. And you can see their forecasts have dropped dramatically, and they're way down here from the long-term average. They're expecting 22% of average on the Carson. And going down to the Walker, this is the West Walker River near the 395 bridge. They didn't get very much out of this, but they did get more snow up in the hills. And so this is rising more steeply. They're starting to see some of the snow melt, and you can see their forecasts are higher with respect to their average than the other 2 rivers I showed. And finally, you go over here to one more stream. This is the Humboldt River at Imlay, which is before it comes into Rye Patch Reservoir. So I should have brought a magnifying glass for this one. But here's their average, way up here, 178. Here's the forecast. Here's how much they've had. And here's the observations. And currently, at the time of this forecast, they're calling for 3% of average stream flow in the Humboldt River.
It's down to 2.
Down to 2, yeah. So it's changed in the. It's still got 2 more to go. But Gary gave a great quote yesterday from I think it's from Mark Twain on that you could Humboldt was the only river you could jump across it 10 times and then drink it dry, and it looks like you could really do that this year. So the Weather Service has got this, the River Forecast Center over in Sacramento has got this really neat little tool that they put together just in the last few days, and a lot of the Weather Service officers are using it. It's quite nice, actually. Rob Hartman, I think, runs a really nice shop over there. And so what you can pull out of this, it might be a little hard to read from the back, is these are all the forecasts of the stream flow, and you can sort of interact with this thing. And for example, there's the West Walker is the highest on this whole map, 64% is the highest. And then there's Rye Patch at 2%. You get upstream, it's all the way up to 4, and then 15. Here's 7. That must be on the Marys River, and 11%. So eastern Nevada, those wetter areas were a little bit more on the south side of this, so the Humboldt hasn't really benefited from this. So, and you can see most of the forecasts, if you can't read them, are in the sort of 40 to 50% range for the Truckee. I think the number is something like 42, 43, 45% for the Truckee main stem proper. But these, they update these in a way every day. There's an official forecast, and then there's a sort of an automated estimate in between. So what about the Colorado River? So basically the issue here is, what are the bathtub rains going to do this year? So this is Lake Mead a few years ago. But first, a little preliminary. This is the history of the inflow to Lake Powell, July through April through July. And these little bars here, they use a reference period. The reference period is always 30 years long. So these are all the reference periods, and the interesting thing that happened between last year, which has a reference period of 1971 to 2000, is the red line. They updated that reference period by 10 more years, from 81 to 2010, and it went from 7,900,000 acre feet to 7,100 acre feet. The normal, new normal, is it dropped by 11%. So this is sort of the expectation is dropped by about 11% or so. It kind of reminds me of, there's a great skit on Saturday Night Live one time about the way women deal with men, and basically their advice was, women, lower your expectations. And that's kind of the way I was looking here, is lower our expectations on the Colorado River system. And it's true also here up in Boise. This is not just that one river system. But so the new forecasts are with respect to a lower mean. So here's the history of the inflow, forecast inflow to Lake Powell, which started out pretty low, and it's been dropping a little bit ever since. They got some storms up there that raised it up, and now it's come back down again, but basically expecting 38% of this newer normal inflow to Lake Powell, and it started to come up a little bit. I mean, you can see it's got a ways to meet this. There's an awful lot of attention paid to this forecast. So here's the storage on Lake Powell, which right now is 47% full, and this is up through day before yesterday. And here's the elevation of the lake, which is now 104 feet below full pool. The record since it was filled is 145 below. That was in 2005. And the projections are, over the next year or so, you take it's not going to rise anymore this year. It looks like we're right about the peak. It's going to very slowly stay the same or very slowly fall. And it's supposed to drop about another 30 feet in the next year or so, because you only get one chance a year to fill it up, and that's in the winter. And then you get what you get and take what happens. And so it looks like it's going to drop not too far from its low value there since the dam was filled. Here's Lake Mead, which is right now at 50%. So this is your perpetual optimist-pessimist issue. And the whole Colorado River system is sitting about 52%. So looking forward to the future, what's our current ocean situation? This actually has an effect on parts of the West, including Nevada and the Great Basin. Well, there's not much going on in this area right here, along the equator between Peru and the date lines, is where we see El Nino and La Nina. Much of the world's ocean is a little bit above average in temperature because it's been rising. I mean, the oceans are getting warmer. And we have cool spots and warm spots. The cool spots are blue on this map. This is from NOAA's Environmental Sciences Research Laboratory in Boulder. And these maps are updated once a week. And then these maps are also updated from the Climate Prediction Center. They home in a little bit more on just the Pacific Ocean itself. And they got these 4 bands you can see down in the bottom here. They're called Nino 4, 3, 2, and 1. And there's one in the middle that's called 3.4. So 4 is way out toward the equatorial regions. I mean, the date line. 1 and 2 are right up next to Peru. And this is the history on the right-hand side here of the last 12 months or so, up through last week. And it tried to form an El Nino. It looked like we were going to have one, and then it kind of petered out a little bit on the La Nina side, but it's right now it's neither fish nor fowl, and it's kind of right in the middle there. So there's not much point in showing this diagram because it shows the effects of those things on the west, so I'm going to skip it. And these are the projections of a whole bunch of climate models about what El Nino might do, and basically the message that you get from all of them is that kind of neither here nor there. Not much tendency toward El Nino or La Nina, and we'll see what happens. So these are the outlooks, the official outlooks for, first of all, for May on the left, and for May, June, July, the next 3 months on the right. Temperature on the left, above average for the western states, below average precipitation to our north, neither nor, but this season doesn't get much precipitation coming up these next 3 months. So May is a dry month, and then above average over most of the U.S. for the next 3 months, and below average over this area for May, June, and July is the official forecast. There's also a set of experimental forecasts under something called the National Multi-Model Ensemble, and basically you can get 6 different opinions, so to speak. It's better than going to one doctor. You go to 6 of them, and so these are different models that are run by the United States. There's 2 from the Canadians. There's 1 from the Geophysical Fluid Dynamics Laboratory, National Center for Atmospheric Research, NASA, and then they lump them all together, and they're sort of showing on the dry side. This is for the next May, June, and July, next 3 months. There's an international version of this that uses some other models, and then on the temperature side, most of them are showing above average in temperature. NCAR is out as an outlier in the middle there, showing cool conditions in the central U.S., but not so much in the west. And when you lump them all together, these are also tending toward the warm side. So I wanted to finish up here with kind of going back to this weather and climate dashboard and some of the reasons why we've put it together here. This gets back to what's going on in the state of Nevada. We put this up after some discussions with Clint Cobley, who's here in the office, and there's the website. And the issue is I haven't shown the drought monitor yet, but this is what it looks like for the western U.S. We have this area here, which is in what's called D3, the severe or extreme drought, and we started the year with much of the country in kind of deep in drought, left over from last year, and it's looking like we're going to be dealing with drought issues in the state. But one of the problems we have in the state of Nevada is just knowing what's going on here. And this is the current secretarial USDA Secretary of Agriculture drought designations for as of May 1st. And you can see all of Nevada is designated as a drought area. It's partly because they use the drought monitor to help make this determination. There's one county that's called a contiguous county. I think it's living in a bad neighborhood, and so drought-wise, so it's almost all of Nevada is labeled as in a drought designation. This has certain implications for relief and programs and so forth. But the issue I'm trying to get to here is you look at all kinds of observing networks, whether it's the RAWS network, the long-term National Weather Service Cooperative network, the airports that we use, or what have you, that probably of all the states, Nevada seems to get short shrift. And we are trying to figure out what's going on in detail, and this really does matter to farmers and ranchers and communities and mining and industry and tourism and recreation and so forth. And knowing what's going on, or people like Erica here, who's looking at butterflies, who they're just as dependent on what the climate is doing as anything else is, and definitely even more so. So how do you know what the conditions are to try to relate what you're seeing, whether it might be with wild horses, which you're going to hear about later on, or any other thing that we're looking at? How do we get the information from there? And we're trying to improve this, both with in situ measurements, maybe remote sensing from satellites, however we can get sort of basically environmental intelligence as to what's going on the ground, so that we can relate this back to what we're seeing in the numbers that are coming in through other systems. So one of the things we're trying to do is, through these meetings, is to sort of foster an awareness of that, and also a way of working with whoever to set up better systems to get information that's more detailed, more accurate, and more rapid coming in. So, just a couple of pictures to close here. I was just at a drought prediction meeting down in San Diego last 3 days, and flying down there, this is some pictures of looking out over Mono Lake and Tioga Summit, looking out the airplane window of Southwest Airlines. This is Lyle Fork. You can see the melting taking place. This is the Tuolumne River. You can see the melting band is proceeding up. That's Mount Gibbs up there. And this is Tuolumne Meadows right here. You drive along the road, and there's the Tuolumne River, taking all of San Francisco's water down to it eventually. And Mount Ritter in the southern part of Yosemite National Park. Snowmelt is on its way there. It's not reached the peaks yet, but you can see it's at work on the lower elevation. So I'll stop there. Thanks.
We have time for a couple questions. Kelly, if you'll repeat the questions, they'll go on the recording.
Oh, okay.
So, any questions? Too much? Yes.
I got one for you, Kelly. So regarding those stream flow forecasts, maybe you or a hydrologist in the audience could tell me, but do you think there is a little bit of a lag to do with soil recharge or just recharge conditions in general that have pushed those down farther than they expected, given what happened the year previous?
So I would say, as a research question and as a practical operational question, the soil moisture issue is probably numero uno on the list of unknowns. Wouldn't you say about the same thing? That the knowing what the conditions are underneath, whether when the snow starts to melt, whether it's going to be whether the soil is already full, the profile is full or not. The SNOTEL system is putting in soil moisture sensors like in Utah. They've got a lot of them, and I think they've done quite a few up here. But that is knowing what the state of the soil water profile is, and especially at the start of winter versus the end of winter. You usually want to get some rainstorms in the fall to wet up the soil column, so when it finally melts, it runs over the top and it doesn't have to pay the tax. Basically, it's tax time, April 15th, but it's a water tax taken up by the soil. And if it goes into the soil, it doesn't show up in the streams, until it finally gets filled up. So knowing what that is, and there's a lot of discussion on how we get at that information. It's expensive and difficult to make these measurements. They're kind of finicky. They're in tough situations. Whatever methods we can use, whether they are direct measurements or inferential measurements from remote sensing or other kinds of things, whatever can help, and then modeling. You just have to have modeling, because we can't measure this at enough places, and it varies so greatly in space. It's a multi-pronged approach we need to get the soil moisture issue, and that is probably the major issue in drought. Knowing, whether we talk about the Great Basin being in drought or not, what's the status of soil moisture? How can we get a good grip on that? That's what all the plants and animals ultimately are concerned about, and humans.
We're eating into your break time. If you want to have questions, we can do that. Do you want to have questions, or?
This is just to follow up on soil moisture, and one of the graphs I put on that talk yesterday, Hydro Partners, was soil moisture, and I can't remember exactly where the data came from, but it was a map of the U.S.
CPC.
Yeah. And the north central Nevada and southeast Oregon are in the driest 1% ever recorded at this point as far as soil moisture. So that shows up in the Humboldt.
So, and I was thinking about using that, but one of the reasons why I didn't was that those graphics, which come from the Climate Prediction Center in Washington, they have a tendency to smooth out the west, and they lump over all the mountain ranges, and you can see the patterns on there. And we need really fine measurements, fine scale, and it's a tough thing to get at. But we need to know the difference between the mountains and the playas right next to them. That's kind of our major issue in the West, is resolving these things sufficiently detailed spatially.